there students, this is Dr. John, your physics and math professor. Today we're going to be looking at Pythagoras' theorem, but previously we had this applied to the sides. So we had this relationship a squared plus b squared is equal to c squared, where a and b are the two shorter sides and c was the side opposite the 90 degrees or the hypotenuse. And we had the relationship that the sum of the squares of the shorter sides, a squared plus b squared, is equal to the square of the longer side. So that's Pythagoras' theorem as we know and love it. But today I'm going to see if I can do this for you in another way where we apply Pythagoras' theorem not to the sides, but to the angle itself. So to do that, we're going to take this here and just see if we can divide it by c squared and see what happens. So I'm going to divide both sides here by c squared. Over here I'm going to have a squared over c squared plus b squared over c squared is equal to 1, because that's c squared over c squared. So over these, I'm just going to reorganize this a little bit. It's going to be a over c all squared plus b over c all squared equals to 1. Now let's take a look at this triangle here again. Remember your definitions. The sine of this angle is the opposite over the hypotenuse. So like this, the sine of theta is equal to a over c, and the cosine of theta is equal to b over c. The adjacent over the hypotenuse. Those are the definitions of sine and cosine. Check a previous video, you can take a look at those definitions. So if you look over here, you realize this a over c is the same as the sine of theta. This b over c is the same as the cosine of theta. Like this, sine theta squared plus cos theta squared equals 1. Now you could write this like this. There's another way of writing it which is considered just as valid, and that is putting the square sign between the sine and the theta or between the cosine and the theta. Both of those ways are completely valid. I'm going to write that over here. So it's going to be sine squared theta, that's how it's read, plus cos squared theta equals 1. This is Pythagoras' theorem, but now we've applied it to this angle theta. This of course would apply to this angle as well. It's the sine and the cosine. This relationship is extremely important. There's not a lot of things I'm going to have you memorize, but you're going to need to memorize this sine squared plus cos squared is equal to 1. It's not that difficult. You can go back to a right angle triangle and just quickly develop it if you need to. I'm going to also develop the same thing over here with this circle. And this is a unit circle. Notice I've drawn this as having a radius of 1. This is 1, 0. This is 0, 1. So that means the hypotenuse here is equal to 1 as well. So here we're going to look at this unit circle, and notice for this angle, I've drawn it sort of the same way as this. This is the opposite, this value here, which is the y value. So this would have an x and a y value right here. The y value, if you can notice that, notice I made the y in red here. The y value would be the opposite over the hypotenuse. So the sine of theta would be equal to y over the hypotenuse, but since this is a unit circle, the hypotenuse is 1, that's just equal to y. So here, in this relationship here, this one here is the sine value, the sine of theta. And this one here, in a similar manner, the x value is the adjacent to this angle. The adjacent over the hypotenuse would be equal to the cosine. So here I've written these values down here and up here. The y value here in this x and y, which lies on the unit circle, is equal to the sine of theta. The x value is the cosine of theta. So if you take a look at this triangle here, this is a right angle triangle right here, and you realize that for a right angle triangle, this squared, x squared, plus y squared is equal to this squared. And what is x squared? It's cosine. What is y squared? It would be sine. So that would mean this would be sine squared theta, which is the y component, plus cos squared theta is equal to 1, which is exactly what we have over here. So that's two different ways you can develop it from the unit circle. You can just very simply develop it from a triangle. So now I'm going to take this relationship, I'm just going to rewrite this up here and erase a couple of things, and I'm going to give you two other variations of Pythagoras' theorem for angles. Give me 2 seconds. So here I just erased a bunch of stuff. I've rewritten Pythagoras' theorem for angles here. Sine squared theta plus cos squared theta is equal to 1. I've also written it here and here because I'm going to do on these two purple ones, I'm going to do a slight modification. You might think, well, what if I don't have the sine and the cosine? What if I have a different trig function? Can I still use Pythagoras' theorem for that? Well, how could we modify this? Well, for one, we could take this and we could divide everything by sine squared. So let's do that. Let's take this and divide by sine squared theta, this term by sine squared theta, and this one by sine squared theta. What would we get? Well, over here, this of course becomes 1. So this is 1 plus, what is this? Cosine squared over sine squared. Well, sine over cosine is tangent, right? And if we flip over tangent, make it upside down, make it the reciprocal, what do we get? We get cotangent, or just cot, like that. So this would be cotangent squared theta, just like that. I flipped over the tangent, and then what is this? This is 1 over sine, and then the whole thing is squared. And 1 over sine, if you remember, the reciprocal of sine is cosecant. If you don't remember that, check out one of my other videos. I've got all that labeled out for you. So this would be equal to cosecant squared theta. So here we have a variation on Pythagoras' theorem that involves cotangent, or the reciprocal of tangent, and the reciprocal of sine. So if you see these things in the basement like this, think cosecant. This is cosecant squared. This is cotangent squared. Here's another variation. You don't need to memorize this. You can just memorize this formula and then think, how can I modify that so I get a sine squared in the denominator? Well, I just divide by sine squared. Next, I'm going to come over here. I'm going to take the same original Pythagoras' theorem for angles, but this time I'm going to attack and try to get rid of the cosine squared. So let's divide everything by cosine squared then. Cosine squared theta here. This term also, cosine squared theta, and then over here, divided by cosine squared theta. This, of course, becomes 1, this term, so that's a very easy one. And this is sine over cosine. So that's pretty basic. Sine over cosine is tangent, and since it's squared, or look at it like this, sine theta over cosine theta all squared, right? That's the tangent inside of there, and the tangent is all squared. So this is going to be tangent squared theta plus 1. Remember what I said before, you can also write this like this. Perfectly legitimate. This is more the tendency of how we tend to write it. And then what's this over here? Well, notice this is the cosine in the basement, in the denominator, the reciprocal of cosine, which is secant. We've covered that in another video as well. So secant squared theta. So here we have the other one. This one, tangent, involves tangent, and cosine squared in the denominator. So both of these are other variations. These two are other variations of Pythagoras' theorem for angles. Again, you don't need to memorize that, but you do need to memorize this or be able to produce it really quickly from a basic triangle. So I hope that helped. Hope you learned something. If you did, like and subscribe, and I will see you in the next video. Bye-bye.